So the next part of the discussion here in chemical bonding is covalent bond. So if you go for covalent bond, here the key word which you have to remember in the case of covalent bond is equal sharing of valence electrons, between two atoms in a molecule is simply called as covalent bond. The valence electrons of both the atoms in the covalent bond belong to both the atoms. The valence electrons which are involving in the formation of covalent bond belongs to both the atoms. Whatever the examples we take, the covalent bond formation, in general the covalent bond formation is more prominent or more significant in the case of homodiatomic molecules. However, the covalent bond is also expected even in the heterodiatomic molecules also. So for example, if you take examples of homodiatomic molecules, examples we can take plenty. That is homodiatomic molecules. Examples you can take H2, F2, N2, O2. All these are homodiatomic molecules. And here, when we are saying equal sharing of valence electrons between two atoms in a molecule, the sharing is done between two atoms in a molecule of their valence electrons, just to acquire stability. So if you take all these are homodiatomic. In general, if you take hydrogen molecule, between hydrogen molecule between two hydrogen atoms, you find a single covalent bond, and in fluorine also you find a single covalent bond. In nitrogen you find 3 covalent bonds, so it is a triple bonded molecule. And if you go for oxygen, it's a double bonded molecule, that is oxygen double bonded molecule. So we can prove the covalent bond formation between the two atoms in all these molecules through Lewis electron dot structure method. So covalent bond formation through Lewis electron dot method. So if we take hydrogen, each hydrogen contains one valence electron. So there are two hydrogen atoms. So one hydrogen is given by a dot and another hydrogen is given by a cross. These two are the valence electrons of both the hydrogen atoms. So according to the Lewis electron dot structure, both the hydrogen atoms of their respective valence electrons, they share equally. That will result in the formation of one bond pair electron. This bond pair electron is shown in the form of a covalent bond. Hydrogen, single bond, hydrogen. This single bond will act as a covalent bond. Next, if you go for fluorine, each fluorine is having 7 valence electrons. So there are 2 out of 7 valence electrons. Each fluorine will try to share 1 electron each, leaving behind the remaining 7 valence electrons. 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6, 7. So you can see that both the fluorine atoms will try to share equally 1 electron with the adjacent atom with each other. So you find that here fluorine molecule has one single covalent bond. Of course, each fluorine is having non-bonding pair of electron, that is 3 non-bonding pair of electrons for the first fluorine and 3 non-bonding pair of electrons for the second fluorine. But a covalent bond is formed successfully between the two fluorine atoms. So if you take the next molecule, that is nitrogen molecule, take two nitrogen molecules. Between two nitrogen molecules, you find that each nitrogen has the number of valence electrons 5. So if you take the number of valence electrons 5, that is 1, 2, 3, 4, 5 are the 5 valence electrons of first nitrogen. If you go for the second nitrogen, 1, 2, 3, 4, 5, again 5 valence electrons of the second nitrogen. So you find that both the nitrogen atoms with these valence electrons, they share equally. If they share equally, you find that the first nitrogen, after sharing equally with the second nitrogen, you find the total number of electrons involved in the nitrogen are 8 electrons, so it is acquiring octet stability. The second nitrogen also, it is trying to share equally with the first nitrogen. So after sharing of electrons, 3 electrons each, after sharing, you find that there are 3 bond pair electrons. So therefore, if you take the structure of nitrogen, it will give 3 bond pairs in the form of 3 covalent bonds, but each nitrogen is having 1 non-bonding pair of electron, okay, for 2 nitrogen atoms each. So you find that here, therefore it is proved that the nitrogen molecule, because it is able to form 3 covalent bonds, it is a triple bonded molecule, but both the nitrogen atoms have already acquired stability, that is octet stability, and hence the covalent bond is formed between 2 nitrogen atoms, and the molecule is definitely a triple bonded molecule. Go for oxygen molecule. There are 2 oxygens. Each oxygen has 6 valence electrons. So 1, 2, 3, 4, 5 and 6. Again 1, 2, 3, 4, 5, 6. You can see here that is each oxygen is trying to share 2 electrons each with one another to acquire the octet stability. So I repeat, each oxygen is trying to share 2 electrons with neighboring oxygen atom, 2 valence electrons of the neighboring oxygen atom. Likewise, if you go for the second oxygen also, you find that the second oxygen also, it is trying to share its 2 valence electrons. Out of 6 valence electrons, it is trying to share 2 valence electrons with the first oxygen, thereby it is giving 2 bond pair of electrons. Because it is giving 2 bond pair of electrons, we can obviously say that oxygen molecule is therefore it is a double bonded molecule with the separation of 2 oxygens, double bonded molecule. It has 2 lone pairs, 2 non-bonding pair of electrons for each oxygen, which is shown as usual. And here what is interesting is, again, oxygen also, it is trying to acquire the octet stability. Here in all the cases except for hydrogen molecule, rest of the 3 molecules, whatever the examples we have taken for the formation of covalent bond, the fluorine molecule, nitrogen molecule and oxygen molecule, with their equal sharing of valence electrons with respect to each other, all 3 molecules have acquired the octet stability. Only the difference is in fluorine, in F2 molecule, you find that there is a single covalent bond. In nitrogen molecule, you can find that there is a triple bond between 2 nitrogen atoms, and in oxygen molecule there is a double bond between the 2 oxygen atoms. So therefore